And we're live. Good morning, good afternoon, good evening, wherever you are in the world. Welcome, welcome. We have a wonderful webinar in store for you. Today, we're going to be talking about knowledge graphs for federal agencies and our work in mapping GIST to basic formal ontology. My name is Joaquin, and I'm the marketing coordinator here at Semantic Arts. With us today is a lovely panel of two ontologists and Steve, our data centric ambassador. We're going to do a brief introductions in alphabetical order, starting with Dylan. Dylan, can you give us a little bit about what you do at Semantic Arts?
Yeah, absolutely. Thanks, Joaquin. I'm Dylan Abney. I'm an ontologist at Semantic Arts, based in Arkansas, and been with the company for about 3.5 years. And I'm one of the developers of Just BFO.
Excellent, thank you. I already went, so I could get skipped. Ryan, would you like to go next?
Sure. Uh, Name is Ryan Hoheimer. Been with Semantic Arts for approximately 3 years. I have been working previous to this in the national laboratory system, so 20 years in the working for Pacific Northwest National Lab in the state of Washington, which is where I reside. And have been involved and in the national security area and cybersecurity for that's my passion. So,
Steve Case here. Appreciate you inviting me, Joaquin. I lead our implementation practice at Semantic Arts, and it's in essence bringing ontology models and semantic knowledge graphs to satisfy some of the data challenges that are existing right now in the ecosystem that most organizations are working in, whether that be federal governments, manufacturing, supply chain, finance, pharmaceuticals. So it's a broad data dilemma that we refer to here. So thanks, Joaquin.
Yeah, it's my pleasure. I consider us partners in crime, so I don't know what all this business is about invitation. But I just want to contextualize this live stream. So we're going to be addressing the mapping of our internal upper ontology that is open source called GIST and the nationally recognized basic formal ontology. Perhaps Dylan can go and give us a little bit of background into both, and then we can compare and contrast a little bit on their relationship.
Yeah, absolutely. So, just as Joaquin mentioned, is the upper ontology that we develop in-house at Semantic Arts, and that's been in active development across 100 different client projects, more than that, really, over the last 20 or so years. So over that time, it's changed and evolved and really been refined. And it's a minimalist upper ontology. It's simple, has roughly 100 classes, 100 properties, and that's kind of one of the design philosophies is to keep it minimal, have the fewest number of concepts to provide the maximum amount of coverage. It's really, when we're talking about upper ontologies, we're talking about domain neutral for the most part. Data models that can be used across a number of different use cases. Um, BFO has a lot of similarities. Um, it's domain neutral as well. It's very abstract. That's kind of one of the differences between just and BFO really is the level of abstractness. BFO is quite abstract. Um, while just, you could almost think of it as more of a mid-level ontology because a lot of the concepts kind of are underneath those that you'll find in BFO. But really a lot of the goals are similar. These are upper ontologies which are designed to promote interoperability. They're realist in a way that they're designed to be modeling the real world rather than concepts or language or something like that. So there's a lot in common, but there are also some important differences too.
I'm going to add, if you don't mind, my popping in here. I'm going to add that BFO, as Dylan had mentioned, is more on the abstract side, the upper level ontology, and that GIST is just below that, a little bit more concrete. And then for individuals like myself that are working in a very specific domain, which is even more concrete than GIST, these three levels of abstraction fit together and plug together, snap together quite well, right? So that I can express things in we're creating at Semantic Arts a what we call a subgist, a gist cyber, an ontology specific for the cybersecurity domain, which builds upon GIST BFO, the integration between GIST and BFO, which sits under BFO. So this relationship between the very abstract, the middle abstraction to the low level domain abstraction, they fit together extremely well because now you're forming a common language between all those levels of abstraction.
So in other words, Ryan, this mapping of GIST to BFO is really just helping with integrations of these different domains across, whether it be federal agencies or across the supply chain cycles. It doesn't really matter, right?
Absolutely. And so since we mentioned earlier that BFO is kind of nationally recognized, where did that come from? It's been around. It's a very mature ontology, been around for some time. In January of 2024, it was adopted, as being the ISO 21838 compliant. So it fits that ISO standard. And the federal agencies have decided that, this is the appropriate way to represent our data structures. But it's very abstract. It's very high level in that sense. But when you get down into the lower level, more concrete domains, such as cybersecurity, cybersecurity practitioners want to work that they've spent their careers working at a very specific expression of their data. And if we have them use that, like just cyber, and they're used to working within the terminology and the concepts within their domain, because we have this mapping between BFO, just BFO, and just cyber, they can continue to work in their domain, represent their data, and basically they get the abstractness of BFO and compliance with BFO with very little effort. They don't have to spend their time thinking about how does this map back to BFO. They get that for free in essence. So that's the importance of this, these levels of abstraction, to make it easier for the practitioners to focus on what it is they do, as opposed to how should I be representing this.
I enjoy the example that you gave, Ryan, on how you go from an upper level concept, such as an event. Something happens at a unique point in time or in a place, and it involves actors, to a cybersecurity related incident event that is maybe someone trying to access something they're not supposed to, right? An incident report. So that's a very clear way of illustrating these concepts to people that may not be familiarized with the levels of ontology or abstractness. Perhaps another thing that we can highlight is the difference between vertical domains, such as like industry domains, and horizontal domains that are functional domains, such as HR, project management, finance. I don't know, Dylan, would you like to talk a little bit about that?
Yeah, certainly. So as I was mentioning more at the outset, a lot of these upper ontologies are intended to be domain neutral, but they can be domain neutral kind of along both of those axes that you mentioned, the verticals and the horizontals. You know, a lot of the client projects that we'll work on with Gist, you know, we'll be developing sort of like sub gists or client specific ontologies that are in one of those more horizontal domains, but our projects can go across the vertical industries too.
Yeah, I have often thought about the differences between representation of verticals versus horizontal domains. Um, and in my case, in my focus on cybersecurity, it is both. Tell me an industry, tell me an enterprise that doesn't have to consider cybersecurity. They all have to consider cybersecurity. But we all know that out of all the enterprises of the world, that some specialize in certain areas. You know, you're going to have your HR firms, you're going to have your accounting firms, you're going to have your firms that develop cybersecurity appliances. So you've got, in some domains, you can't really say, okay, this is a vertical or this is a horizontal. They're both.
Great. Sorry, Steve, were you going to say something?
Just you know, I know that, you know, semantic arts, one of our themes is simplicity, and in referencing that in the context of how we're looking at GIST and BFO, and just really trying to address these bigger challenges of mapping these different ontologies together. Can you guys give just a little bit more depth on how that kind of fits into, you know, the bigger picture, and like I said, from an adoption standpoint, for non-ontologists that are just really looking to just get the most use and optimize the data that they have access to?
Yeah, I can start off on that one. As Ryan mentioned earlier, you know, we saw that this could be a useful tool for folks, and that's, you know, this we started looking into this mapping. It was probably over 2 years ago at this point when we started to hear rumblings of, you know, the need for alignment with BFO and an interest in it, right? And we had the thought, well, why don't we create this kind of mapping to help people out, to be able to more easily align with BFO, because that's, you know, we see that as one of the major strengths of Gist, is that you can use this on your projects and it's really going to kickstart ontology development, because the terms are a little more ordinary language. These are terms, you know, the meanings of these. It's like person, account, project. These are all very familiar terms, and you don't need to spend much time thinking about whether various divisions in your organization are organizations. That's easy to put in the organization bucket. It's easy to make these sort of classifications. You know, if you're trying to figure out whether your organization, though, is an object aggregate or whether it's an immaterial entity, which are some concepts you might find in BFO, that's going to take a little bit more time. And, you know, maybe there's a good answer to that question, but certainly at the beginning stages of your project, you don't want to get bogged down in those kinds of decisions, right? And so this is kind of the role that we see this mapping taking, is being able to really kickstart these projects, you know, get going with ontological development, and you can start to realize some of the advantages at an early stage, right? You can start to get some of those benefits, you know, whether you're trying to get better analytics, you're trying to get interoperability, being able to do federated queries across systems, like you're going to get those at a much quicker stage, if you're using Gist.
So yeah, you're spot on, Dylan. You're spot on. It's a matter of, GIST is not an acronym. living in the government and the laboratory environment, we're inundated with acronyms. The thing about it is, GIST is just a representation of what it is that ontology is to express the gist of the situation. And so this is the simplicity that we're talking about here. We wanted to prepare and have prepared something that allows us to express the gist of the vocabulary of our situation. The important thing that you just touched on, which starts to make that bridge between the very specific domain ontologies and that upper ontology. In cybersecurity, practitioners often talk about threat actors. Well, those are the bad guys. Those are the guys we're trying to protect ourselves against. Those are the guys that are taking us through these threat life cycles that are going on. But a threat actor can be an individual or it can be an organization, and an individual and an organization is expressed in GIST, and it maps to the organization and the person that's in BFO, and that again maps up, as you had mentioned before, an immaterial object that's an organization. These things allow our practitioners in a specific domain to refer to things by the terminology that they're used to. They've developed a career to understand with their cohorts what a threat actor is, or what a threat is, what a risk is. And by providing GIST cyber and GIST BFO to BFO representation, they get that connection that allows them to start that semantic interoperability with many other systems that are developing concepts in their domain as well. I probably made that as clear as mud, but there's a significant advantage to working with a simple representation of the knowledge and the data that you've got mapped back to an upper ontology like BFO.
I came into the space of knowledge graphs and semantic technologies about 4 to 5 years ago, and I was really excited about the idea of ontology serving as a knowledge blueprint that allows people to communicate with people and people to communicate with people via machines, sharing the same kind of schema of understanding. But what was more exciting for me when I came aboard Semantic Arts was that you had boiled the schema down into a semantic Lego building set. So I really like being able to cast ideas and build things very rapidly with predefined concepts that work out of the box, Um, maybe we could talk a little bit about and reemphasize the value of ontologies or upper ontologies as a starting point. If we start a project in the HR domain in a horizontal function in a pharmaceutical company, could be any kind of company, but let's start here. If you start there and you want to start a project in another part of the organization, if you're starting from the same upper ontology, you get to tie them together for free, right?
Yeah, that's one of the major benefits of using an upper ontology like GIST. I mean, if you're working across organizations within a larger organization, across horizontals, right? One of the philosophies that we'll use on our client projects is think big and start small, right? And so what that means in practical terms for us a lot of the time is thinking big about the different various domains that you could go into with a project and where you could extend the knowledge graph, but starting small with a particular domain and building things out there. But what the upper ontology allows you to do is once you've started with one of those domains and you've built a specific ontology, it becomes that much easier to move into the next domain where you've already modeled people in HR. Well, people work on projects. And so it's important that you've modeled things in a particular way in one domain so that you can easily move into the next one.
I want to expand on that because you guys have touched on something that is really close to my heart. And that is that throughout BFO, just CCO, just cyber that I'm working on, the ontologists that have worked on these representations are like myself in that they're knowledge, representation, and reasoning folks. And that I'm emphasizing the word reasoning here. Why am I doing that? Because these representations aren't just kind of off the cuff thrown together. A great deal of energy and contemplation went into the formation of BFO, went into the formation of GIST to keep these data structures that we're defining with an ontology logically consistent. And so one of the advantages to using BFO, just BFO, just cyber, is that the ontology, the data, the knowledge, representation, and reasoning folks, like us at Semantic Arts at Buffalo, the University of Buffalo, these we've spent a great deal of time making sure that this data structure definition that we're creating is logically consistent, allowing us to use description logics reasoners to use the facts that are stored in these graphs to infer new knowledge. Dylan just mentioned, yeah, people have a relationship with organizations, I think is what you said, or that. There are logical relationships between entities, and we can use that logic to infer new things, right? And all of that work has been embedded within these constructs of BFO, just BFO, just cyber. The practitioner down here trying to figure out, is somebody threatening to breach my company doesn't have to be thinking about logical consistency. He gets that because he's using this framework. And that's important.
Yeah, I think I'll jump off of that point too, Ryan, to say a little bit more about some of the methodology behind uh, just BFO, the mapping that we've been working on. Logical consistency was one of those main considerations with the mapping when we were linking these two ontologies. That's not something that was, necessarily easy to arrive at, but it was one of the things we were trying to balance, logical consistency, making sure that we weren't generating any contradictions or anything like that with the mapping. We also wanted to stay true to the spirit of the definitions within GIST and BFO. So not necessarily looking at the formal definitions that we see in the ontologies, but looking at the annotations, looking at some of the background knowledge that we have about the basic formal ontology and better understanding some of the intent behind the gist concepts to really make sure that even if it didn't generate a contradiction to place one gist class under another BFO class, was that really the intent behind them? Does it really make sense to put those to connect those two classes? Another thing is making sure that there's genuine compliance with BFO. I say genuine because, it's like one thing we could have done is put all of the GIST classes under BFO's top level class, which is entity. But that wouldn't have been interesting. It wouldn't have been genuine alignment in a sort of interesting way. So that's one thing we tried to do in the mapping was to place everything under the most specific class in BFO that we could. And then finally, we tried to anticipate a potential alignment with CCO, the Common Core ontologies, which, we could talk more about that in the future. That's something that's under consideration for development, but, that kind of guided the mapping we made as well.
One of the things that I enjoy is when you're working at understanding and developing the relationship between BFO and GIST cyber, Also, there's another sub just in there, just computing. There's an awful lot of overlap with that domain. It's fun. Boy, that really is an interesting definition of my term fun. You pull together a visualization of the BFO ontology, and you start understanding the relationship, the subclass relationships that just has with BFO. You start to see that these more specific concepts start folding into their more upper level ontology. So I'm working down in just cyber security related concepts, which folds into BFO with these mappings that we're creating. And so when you look at like we're all used to looking at in Microsoft Windows, a tree representation of these concepts, they all fold in underneath the upper level ontology. You open up the ontology and look at it in that fashion, and you see BFO, and then you start to open up each of these concepts, and it expands and gets more specific and more specific. Somehow or other, that's interesting and fun to me, but I'm a geek.
That's a great point, and it gives a lot of room for interoperability. We mentioned the benefit in horizontal expansion. So you start in HR, you go to projects, you go to finance, you go to accounting or reporting. There's a lot of benefit there, but because these two things have been around for some time, there's also global interoperability with other things that have been built off the same standards. Like there's BFO derivatives to the life science domain. I'm not an ontologist, so I can't speak intelligently about those domains, but being able to map to BFO gives you a compatibility to those domain-specific ontologies on molecular compounds and diseases and other things that are really interesting that I can't talk about, but that's cool. And what other benefits do you get, Dylan and Ryan?
I'm going to pick up on this, and might be Dylan, your experience as well, but using a mid-level and an upper-level ontology for semantic interoperability. As I was mentioning before, in the cybersecurity domain, you've got lots of different entities trying to resolve the many different threat scenarios that might be involved. So you start looking at things like, what is the definition of a vulnerability? What is a vulnerability? What is a software product, right? What is software? What kinds of software are there? There's all sorts of different kinds of software for all those different horizontal and vertical domains. You've got the concept of controls, right? We've got Center for Internet Security that's trying to develop an understanding of how and to, in an automated sense, actually recognize threats and apply the appropriate mitigation control automatically. And you've got the concept of crown jewels. And by that, I mean, what does an enterprise consider to be valuable to them, and how are they going to protect it? You've got a myriad of different concepts that are being addressed by a huge number of different enterprises. So by using these ontologies like this that we're suggesting be done, and we're helping clients bring in semantic interoperability between all the different subcomponents and systems that they have within their enterprise. This is where we at Semantic Arts try to consult clients to bring them towards what we call data-centric architectures. Steve, you're probably the guy that could speak to that more eloquently than I can. But my point is that the primary value that I see come to using these ontologies the way we have is to create the semantic interoperability between the disparate different systems that an enterprise might incur.
Yeah, that's a great way of looking at it, Ryan. And I know we've talked a little bit about, well, in depth, I'd say, as to why we did this, why we made this mapping between BFO and GIST, and part of our theme here is around federal agencies. And I mean, just as ontologists, Dylan and Ryan, what advice would you give for those agencies that are looking to implement a GIST or BFO or any type of ontology, or for that matter, mature that ontology? What advice would you give them?
Yeah, I can start with that. I think, one of the initial bits of advice that I would give is to try out Gist, use Gist, and just get started with it. Because I think it's, if you have some experience with ontology development, and then you spend some time with Gist, you can see sort of that immediate payoff. You can see that you're going to get things rolling pretty quickly. That's what we tend to see on our client projects. So that would be my initial bit of advice: is get started with that. And as we've said, you can see how things start to align with BFO, and you can also get some of those initial benefits. We see this with proofs of concept that we develop with initial just kind of sample data sets. We can quickly see that the interoperability is there, that you're going to get these deeper you can have deeper analysis with queries, in part because of what Ryan mentioned earlier about reasoning. Um, and you're really going to be able to make some connections that were either difficult to make in the past, or maybe even impossible to make in the past, given the data silos within an organization.
I think that I'm getting long in the tooth, and I've been around for a long time. I think I wrote my first computer program back in 1973. So, I've been poking around software and data structures and data alignment for a long time. So some of the advice that I would give is to reverence the relationship between your subject matter experts, those guys in the field that are practitioners that are doing their job day in and day out, and the knowledge representation and reasoning guys, right? And these were typically, for 70s, 80s, 90s, these were your programmers, right? And then we transitioned into object-oriented programmers. So getting your subject matter experts, communicating with your data science guys, your computer science guys, and get them thinking in terms of object-oriented data, and get them away, and make sure that your ontologists, your data scientists, your programmers are listening to the practitioners, your subject matter experts, and guarding against the subject matter experts trying to take over the programming, because that happens. But that relationship between your subject matter experts and your data science guys is incredibly important. So you've got to put on the listening. We call it knowledge elicitation and extraction from the knowledge experts, so that we put into our ontologies the level of thinking and the logic. It's not just the description of the data, it's the description of the logic that they use to process that data that gives us that ability to make inferences. And listening to that, that's the biggest, strongest advice that I can say has to happen, is that listen to the subject matter expert for not only their description of what they call data, but the logic that they apply to that data, so that we can capture it in the ontologies.
I'm so glad that you brought that up, Ryan, and I didn't tee that up on your behalf by any means as a pre-set up a thing, but it just so much of a common sense approach is that you need to have that level of communication between the ontologists, the modelers, those that are really trying to represent that knowledge, and the SMEs. And neither one of them should be talking over one another, but finding where that common language lies, and
Yep.
then just bringing these conceptual models that can really help in assisting in pulling that all together, and in essence creating, like you said, this common language across multiple domains, getting these schemas to align, and that in essence is the value associated with what we're trying to achieve here.
Ryan, you gave me a trigger word, elicitation, knowledge elicitation, a good triggered word, good word, not in a bad sense.
Okay.
And prior to that, you said semantic interoperability. I think there are some things that we're taking for granted in this conversation. Knowledge elicitation, requirement elicitation is something that is commonly practiced in software development as it stands today. And it doesn't out of the box provide semantic encoding into the code development. Usually people take requirements as functional specifications, turn them into design specs, and then go and code it off into some sort of thing that's using whatever kind of database, whether it's structured, semi-structured, or graph-based, whatever. What we're talking about is being able to reference this to some globally recognized link data that can provide that semantic interoperability inside of your organization and out into the world. So I wanted to just bring that into the conversation so we can reinforce that this is a way to make sense of things with the world, not just within your organization. You get a lot of benefits alongside this kind of exercise.
What you just said there resonates with me. It is summarized for me in that we need to start moving away from being application centric to being data centric. In other words, we need to model the real world and understand that way that we look at our world, that look at the real world, and the data that's involved and the logic that's involved with that data in our real world is something that applications can access, and multiple applications can access that centralized data structure and use it. Whereas up to this point in time, with software development over the last number of decades, we tend to use software to solve a very specific problem, and we're application specific. And so we're in the process whenever possible to help our clients understand how to move from this set of independent stovepipe disparate applications to a more data-centric model of the real world that can bring that semantic interoperability between all those applications together.
I might be throwing a curveball here, but I'm going to throw it anyways. Now, traditionally, people are used to the consumption of REST APIs or these sorts of things that, in software are prolific. Oh, what kind of API are you consuming to do that kind of function? What are we proposing as the alternative with ontologies? And why is that adding value through the semantic lens?
What we're proposing is to start building things off of BFO and GIST and using those high upper level more abstract concepts to be central to representation of the real world. I mean that's what's happening here. Is if we can start representing the real world as would be useful in these individual domains, then we facilitate the creation of APIs and interchange of data that's formulated on that centralized model of the world. So it facilitates better APIs and better interaction and better exchange of information because we're working with a common language.
To bridge this over to the space, the environmental characteristics of the federal environment, can we talk a little bit about what it's like working in the federal agency or federal adjacent use cases and the secrecy involved, the fragmentation, all that jazz?
All that jazz. Yeah. Dylan, you want to go or do you want me to go?
Yeah, sure. I can say a little bit about that. It it is important to talk about the nature of federal agencies and the specific needs that these organizations are going to have and why it makes it that much more important to have your data in order and to have this sort of data centric mindset rather than the application centric mindset that Ryan just described. Um, particularly given the potential scale of the data that you're working with, and as you mentioned, Joaquin, privacy and security concerns. That's a big part of it as well. Um, Again, it's that much more important to make sure that you've got this single model in place that you can use to build, your data model off of a more specific you know, domain model off of that. And yeah, I think it's definitely an important thing.
I have an interesting perspective of working with the federal agencies and related enterprises to that. And I look at these as really cool data sources. These are subject matter experts, at the organizational level. But think of NIST. I mean, they've spent a huge amount of time documenting a domain or many domains, right? And so I look at the interactions with these agencies as, wow, that's an incredible source of knowledge that can be encapsulated in our ontologies. You look at MITRE, and all your FFRDCs, they're spending dollars developing an understanding. They're doing the research and development in areas that's a wealth of information that needs to be encapsulated in our modeling of the world that we're trying to express advancements in. And so, you start looking at these different entities that are developing controls, that are developing an understanding of just indexing all the hardware and software that we have out there, and start talking about resilience. How do I become a more resilient enterprise? These agencies are a wealth of information. And so the challenge then in working in an environment where you've got access to different agencies and therefore different facets of the knowledge that you've got, your ontology under development needs to interweave these things together. And this is where upper level ontology like BFO become really powerful, because you start collecting, well, what are all the immaterial entities in this set of knowledge that's being described to me? And as you start, mapping things back up to that upper level, then you can start to make queries that say, well, what does MITRE think are their immaterial entities? What does NIST think is an immaterial entity? And I'm just using that as one example out of BFO. And you start to be able to create a representation of the the holistic knowledge and be able to query it to see where the commonalities are. And that's really important.
At an operational level, I think that also gives some operational efficiencies and ability to acclimate to different domains in a more trusted way. I've been a technical project manager. I've gone into projects where there's no documentation. And when you talk to the engineers, you have to interrogate them to tell you what that API endpoint does, what it leads to, what it's touching. When you abstract this concern with semantic interoperability, now there's something that has meaning encoded into it, that has the documentation baked into it. So meaning and the data are both entwined. I really enjoy that aspect of being able to work in these areas, you know.
Mm-hmm.
Otherwise, it's looking at tables and queries and trying to work backwards as a archaeologist digging away past civilizations. What the hell does this mean? Where does this lead to? It's a pain in the butt.
Yeah, it's definitely one of the advantages, that we see working with semantic technology like RDF and OWL is that the meaning, that data kind of wears its meaning on its sleeve, right? It's baked into it, and that's what it's all about. So when you're reviewing an ontology, you're looking at the data, the meaning is very transparent and it's sort of self-documenting in that way.
So the buzz around AI and Gen AI and certainly federal agencies are strictly concerned about security and how all these things can be turned into hallucinations. How would you provide some understanding of whether it be GIST or BFO or how ontologies kind of play a role in these kind of learning initiatives and whether it be for any type of a project?
Well, Dylan, you look like you were about to respond to it.
Yeah, sure. I'll go ahead and start, and I'll pass it over to you, Ryan. It's a great topic, Steve. AI and Gen AI, and the relationship of ontologies and knowledge graphs to these initiatives. And we're definitely seeing that there's a lot of appetite for for Gen AI and getting that involved in your organization because it can be really helpful to just give natural language queries and get information back. But as we've seen, one of the big challenges there is hallucination and making sure that you've got accurate information that you're actually getting back from these systems. And in the realm of federal agencies, I mean, that's going to be particularly important. You can't sort of just have those hallucinations lurking in the background and just hope that everything's okay. And so some of the things that we've seen is we've seen initiatives to sort of integrate graph technology and LLMs and generative AI as to sort of tether the LLMs to reality. So that's one thing that a knowledge graph can do. Um, and so that's like, before is another thing that we say, before starting an LLM project, you really want to make sure your data is in order. Because if you've got bad data, it's going to be, kind of a garbage in, garbage out scenario. But if you've got your data in order, you're using an ontology, you've got this data centric mindset, it's going to be that much easier for a potential Gen AI project to succeed.
Yeah, it's a good call of caution there, Dylan. Is that get your data in order before you really pursue these things with a great deal of vigor, because the results are just not going to be very reliable, and you want to have that trustworthiness associated with that. So great perspective, Ryan. Do you have more on that?
I do. So you think in the national security, you think in terms of the DoD and the IC, and you think in terms of that domain, And you'll have policy makers, you'll have decision makers that go to an analytics team and say, I need the answer to this. I need intelligence on this topic. I need answers, you know. That decision maker, when he receives the report or receives the answer from the analytics team, he wants actionable intelligence. You're asking me to pull the trigger and the consequences of that are extremely high. I need to know why. I need to know with confidence that the answer you're giving me allows me to pull the trigger, right? To do something that may have significant consequences. You know, I need to know. You know, let's go to the cybersecurity domain. I need to know if XYZ employee is breaching policies, right? And so the analytic team goes off and looks at the situation and comes back and says, yeah, there's a breach, you should fire him. You know, well, I got to have confidence that you're telling me I should fire him, and I need to know why you're telling me you should fire him. So what I'm saying here is that the decision makers and policy makers need to have confidence. They need to have actionable intelligence. They need to have actionable results from their queries, their inquiries. How does this relate to LLMs and graphs and that? Look, LLMs were designed to do natural language processing. And so we've all, you know, used a Gen AI and asked a query and got back an answer. And you kind of, how'd you get that answer? And even to the point we go, oh man, that's a hallucination. That isn't even right, right? But as we progress, the appetite for not just processing natural language, but augmenting that knowledge with controlled language, which is what an ontology is, and a knowledge graph holds facts governed by that controlled language. Now we get from the point of being able to say and make a query, a question, and get back an answer. And there is semantics associated with the result. This makes that result actionable intelligence. I know why I got this answer, as opposed to I got an answer, but I can't tell you why I got it. So the augmentation of these Gen AI systems with graph regs and you know, augment the results with a controlled language, such as you would get from a knowledge graph governed by a particular ontology, makes the results actionable, or at least elevates the confidence that can be had in the result.
I like that, I like that distinction. Ontologies are deterministic, so there's no room for misrepresentation of facts unless someone mismodeled something accidentally, you know. But usually there's a lot of rigor in the development of these ontologies, and you get the reasoning capability, so you can extend. You know, if I want these things, I can also look at these subsequent things that are tied to this particular node of information. Um, but LLMs indeed are great interfaces. People have tried to use it as a reasoning, or you know, they say it's intelligent, or they say it does a lot of things, but it's just statistically giving you a likelihood of something that you may want, and not even based on facts, right?
I'm gonna tweak that a little bit, and you know, shameless plug here. That's why you want to work with somebody like a Semantic Arts or you know, from an institution, you know, University of Buffalo or whatever, because you can. It is not impervious. You can embed in an ontology bad logic. I mean, there is, you know, there's the logical fallacies. There's many logical fallacies that you know, we as humans have, and we can embed those logical fallacies into our ontologies that would lead to bad inferences. But if you work with groups like the semantic arts and as I said, there's other institutions out there, but semantic arts is who I've chosen to work with. We can avoid representation of many of these logical fallacies. And you even with ontologies, if you have some of those biases in your logic, you can embed those and make inferences that are wrong. So you need to guard against that.
So I'm being a little tongue in cheek here, but so don't use LLMs to build your ontology, right?
No, that'd take a whole nother hour. Ontology induction from data is bogus in my mind, not entirely, but ontology development from subject matter experts that have spent years and years learning the topic makes sense, but trying to automatically derive an ontology from a bunch of data, you need interpretation of that data. You can't I'm sorry, I just don't feel that there's a lot of strength in automatically generating an ontology based off a pool of data.
So we have some comments, questions, concerns. Not really concerns, but just comments and questions. Ali's asking what's the link to the repo, and William was kind enough to share it. He also shared the protege flavor. What would you call this, Dylan?
Yeah, so this is the link to the ontology itself. So this could be plugged into Protege, and that'll return just core. Another thing we can do, I'll be sure to do it if it's not in there already, is to provide a link to the GitHub repository for the just BFO mappings, because this is something I probably didn't emphasize earlier, but it's a work in progress. It's our first kind of first take at the mapping, and it is something that we encourage a lot of input on. We're lucky enough to be working and collaborating with the group at the National Center for Ontological Research to get their input on the mappings too. And we think we're just going to be refining these over time. So we'll definitely link to that as well if anybody's interested in contributing.
Kate shared it in the comments right here. This is what you're referring to, right? Just BFO?
That's it. Excellent.
Right. Thank you, Kate. So we have a few more comments. Christopher says, very close to the work I've done with the DODAF. Used the original work built by European Working Group Ideas. He says SME input into any ontology is critical.
Yep.
And the business rules of the data are also incredibly important. Mara Abel is saying that she's working in her PhD defense, classifying terminology in BFO using LLM over textual definition. Very cool. Best of luck.
Interesting.
How it goes. We'd love to have you, in a live stream as well. Talk about that. And I think that's about it. Christopher also said the dangers of using LLMs to construct your ontologies may also introduce malicious logic. So might not just be wrong answers, but contrarian answers that are going to be unproductive and destructive to the business conduct. All right. Anything else that we'd like to conclude the call with, Dylan, Ryan?
Wouldn't say much other than appreciate everyone's time, and it was great to be able to share some of the work we've been doing on this, and really looking forward to actually implementing it, getting some folks using this mapping and seeing the benefits realized.
Yep. Time to go back to living the dream, guys.
Steve, you want to put a bow on it?
Well, Dylan said it's an iteration. It's a living and breathing model that we're always looking to refine and enrich, and we just take circumstances that are in the real world and apply those. So getting it out there and applying it, I think, is the biggest thing. And then we learn along the way and adapt as well. So thank you all for joining us. We got others that are going to be coming out in the future. So keep in touch.
Oh, last thing, I don't think we mentioned it was with the GIST, we have GIST extensions into finance, pharma, and they're very mature. We use them in our own client projects. If you would like to get support using GIST for a project, pilot, proof of concept, whatever you want, give us a call. We're happy to help.
Don't forget to mention just cyber. It's rolling out here soon.
I can't. You said it. So thank you all.
Thank you.
Thanks.
All right.